So in this video, we are going to discuss about the time response of the first order system when unit ramp input signal is given. So we know that T of S does nothing but C of S divided by R of S. This is my output response and this is my input response. That is equal to 1 divided by 1 plus S T. This is a uh, first order system. Okay, so here the RFS is my input. Here the input is a unit ramp signal. So we know that R of t is equal to t, right, for unit ramp signal. So if I take a Laplace transform, it becomes 1 divided by s square. So I substitute C of s is equal to 1 divided by s square into 1 divided by 1 plus st. So for this one we can take partial fraction, right? So I can write it as a divided by s plus b divided by s square plus c divided by 1 plus st, right? So this is equal to as into 1 plus st plus b into 1 plus st plus c into s square. That is let me equate this one to 1, right? Because this is equal to 1 divided by s square into 1 plus st. So here also if I divide this one, here also I will get 1 divide s squared into 1 plus st. So these two get cancelled out, right? So I can write a s into 1 plus st plus b into 1 plus st plus c into s square is equal to 1, right? So bring this s inside. So a s plus s square t plus b into 1 plus st plus c s square is equal to 1. So that I can write, so if we equate the constant term, you will get b is equal to 1, right? And if I equate s square term, I will get at plus c is equal to 0. Likewise, if I equate the s term, so here you have s, here you have s. So a plus pt is equal to 0. So b value is 1, so a value is equal to minus t, right? A value is equal to minus t. So we substitute it here, minus t square plus c is equal to 0. So c is equal to t square. So you substitute it here. Okay. So what is a? A is t, right? A is t or minus t? A is minus t. So a is minus t, substitute minus t divided by s plus b value is b is 1. So plus 1 divided by s square t square divided by 1 plus s. Okay. So again I am writing here the same equation. Cs is equal to minus t divided by s minus t divided by plus t square divided by 1 plus st. So before so here this term I can again write, bring this t outside. If I bring this t outside, I will get t divided by 1 by t plus s, right? So if I take a inverse Laplace transform for the above equation, I will get c of t is equal to this minus t. I can take it outside. So this 1 divided by s is 1, right? plus this is nothing but t square plus if I take t outside, this becomes a e power minus 1 divided by t into t. Okay. So this I can rewrite it as so this is not t square, this is t. I'm sorry. So the Laplace of t is 1 divided by s square. So t plus t, if I take it outside, I will get minus 1 plus e power minus 1 divided by t, 1 divided by capital T into t. Okay. So if I take minus t, minus outside, this becomes 1 minus e power minus 1 divided by t into t. So this is my C of t. In order to measure the performance parameter of the first order system, performance parameters of the first order system. So first we will discuss about settling time. Okay. Settling time. It is nothing but T of s. So what is T of s? T of s is equal to T when C of t, right? C of t is equal to 0.98. Okay. So what is the definition is, it is a time taken by the response of the system to reach time taken by the response of the system. What is the response of the system? That is C of t. It's a response of the system to reach, so to reach 98% of the final value. T must be in terms of some value of t, right? It may be either 4 of t or 5 of t, 6 of t. Like that, if you substitute, you can find the answer of C of t is equal to 0.9. Next one is this is my first performance parameter, and the second one is rise time. So it is it's a time taken by the response of the system to reach the 90% of the final value minus, or 90% of the final value from 10% of the 10%. So I can write this T of R is equal to T when the C of t is equal to 0.9 minus T when C of t is equal to 0.1. Okay, the third one is delay time. So it is represented as TD, that is equal to when C of t is equal to 0.5. That is the time taken by the response of the system to reach the 50% of the final value. Okay, and the fourth one is steady state error. So this is represented as ESS. Okay, ESS. So the ESS is I can write it as limit it t tends to infinity when R of t R of t minus C of t. Okay. So this is the input and this is my response. Okay. So the response is nothing but C of t. So it has a difference that is existing between the standard input applied and the output that is obtained from the system. Right. When the any input is given. So here the input is a ramp signal, right? So if I want to find the response, steady state error, uh, I can write this t infinity e of t, right? So e of t is nothing but r of t minus c of t. So in other words, I can write limit s tends to 0, s into r of s minus c of s. And this way also you can write it out. So for this system, we have obtained the value of c of t and r of t, right? So for the unit ramp signal, what is my steady state error? So you substitute on the above equation. Okay. If we substitute limit t tends to infinity, r of t minus c of t, substitute it like this. Okay. Limit t tends to infinity, r of t is nothing but t minus c of t is what is c of t? T minus t minus t into 1 minus e power minus t 1 by t 1 by t into t. Okay. So here the second write it as t into 1 minus e power minus 1 divided by t into infinity. Okay. So e power minus infinity is 0. So you will get the answer as t. So my e of s is nothing but t. Okay. So what it represents is for so this is my r of t, right? R of t with respect to t. So you will get the answer as since it is a ramp signal, it will be like this. So if I plot for c of t, okay, my response has to be like this. For if r of t is like this, this is my input signal. The c of t must obtain like this. But I have a error. E of s is equal to t, right? This is nothing but r of t minus c of t, right? Once again, it is small r of t. Okay, so um, so the response has to be like this. So at t equal to some value, so you will get the difference as t, capital T. Okay, so this is my uh, steady state error. So this is my uh, steady state error. The first order system we have taken here. We will track the unit ramp input with a steady state error t. Okay, so this is what I have to tell. So next, if you want, so the next lecture is what happens when the first order system is subject to a unit impulse input. And there we will discuss about the rise time and delay time and settling time, etc. Thank you.